So let's see one particular example with numbers. So we have now this reaction of titanium dioxide with carbon to give titanium, metal, and carbon monoxide. The problem states that we have a certain amount of carbon and also we're given a certain amount of titanium dioxide. Also, the problem gives us that the actual amount of titanium being formed under these conditions is a certain amount in kilograms. Now, what you have to recognize in this problem is that we're not just given the amount of carbon or just the amount of titanium dioxide, we're actually given specific amounts for the two of them. So these two are given already in the problem. Every time we have at least two specific amounts of reactants as part of the data on the problem, we have to check if there's a limiting reactant, if either of them is a limiting reactant. If we detect one, that's going to give us basically the theoretical yield for our problem. The limiting reactant bounds the total amount of product that can be formed, so given the theoretical yield. And since we're also given the actual amount of titanium formed, we can now, with the actual and the theoretical amounts, we can calculate the percent yield. So how do we proceed in terms of numbers? So the first thing that we have to do is identify the limiting reactant and calculate the theoretical yield. Again, we're giving two amounts, carbon and titanium, so we have to do two stoichiometry calculations. So that is thinking that all the carbon is used and calculate the amount of titanium that can be produced. And the second one is thinking that titanium dioxide is completely used and calculate the amount of titanium that can be produced. So these calculations are done exactly the same way that we did in the previous video. It's a stoichiometry calculation. So we can end up calculating the amount of titanium that it's being produced with each of those two components, carbon and titanium dioxide. Now, the next step is compare those two numbers. So look at this. We have 1.27 versus 1.37. So obviously, this amount is the smallest amount of the two, so that means that titanium dioxide is going to be characterized as the limiting reactant because it produces a less amount of a given product. By the way, the product that we can calculate, the amount of product that we can calculate could be either titanium or carbon dioxide. The reason for this particular problem to calculate the amount of titanium is because the problem already gives us a given amount of actual product titanium. So this reaction was interested in calculating the amount of titanium. So now that we determined that titanium dioxide is a limiting reactant, the amount that is produced by this particular compound is going to be the theoretical yield in moles for this problem. In particularly for the way that I'm arranging the answer, it'll be in kilomoles of titanium. The second part of the problem now is calculating the percent yield. Since we are giving an actual amount of titanium forming this reaction, and we already calculated the theoretical yield from the limiting reactant in the previous step, now what we can do is to take the ratio between those two and express that as a percentage. When we do this, remember, the key point is that both of them should be in the same units. Our theoretical yield was calculated in kilomoles, so what we can do is either convert that into kilograms or having this actual amount in kilograms, converted it into kilomoles, such that now when we take the ratio, we can cancel the units. What I did here is to convert from kilograms to kilomoles of titanium. So now the theoretical and the actual yield are both in the same units. We can cancel those kilomoles of titanium, and we end up having around 80.9% if we follow the significant figures. Again, important thing, make sure that you have the same units.